Routes are how your API maps HTTP requests to the code that needs to be run. Express lets us set up our routes in a modular way using router instances to organize related routes and middleware into a single file. In this tutorial, we'll create modular Express routes for our API using a router instance. We'll handle errors in our response handlers when using async and await, and we'll create a middleware that is scoped to our router instance. We're going to create route handlers for our API proxy, which will retrieve data from the Exoplanet API, transform the planet data we received, and then send it back to the client. So first, let's create a routes directory in our project and a planets.js file in the routes directory. Our planets file in the routes directory will hold the routes to get planet data. Let's go over to our editor and open the planets.js file. First, we'll require Express and then create a router instance using the router constructor. We'll also export the router from the file so we can require it later in our main index.js file. Now we'll stub out the routes that we want to create. Our routes are going to be /planets and /planets/sense year. We're leaving off the planets part of the route string because we will be mounting this router instance at the /planets path with the Express application. That means that any path this router defines will have /planets appended to it for us. Our second route is using a path parameter called year, which will be available as a parameter to our response handler. With the stubbed out routes, we can go ahead and register the router instance with the app in our index.js file. We require the planets router from the planets file and then pass it into app.use, mounting the router under the /planets path. Now we can start the server with npm run dev and open a browser to localhost 3000/planets. There, our routes are working properly so far. Now we'll implement the actual response handlers in the routes/planets file. Let's require the request functions and transform functions from the Exoplanet module we created earlier. Now we'll create a response handler for the /planets route to retrieve all the planet records. We're going to use async and await, so we need to mark the response handler as an async function. We'll use getAllPlanets to request the planet data from the Exoplanet API. We're awaiting the request and assigning the returned value to raw planets. Then we'll map over the raw planet data and run our transform function for each record. Finally, we use rest.json to send the array of transformed planets back to the client as a JSON payload. After saving the file, open up a browser window again to localhost 3000/planets. This request might take a little while because the Exoplanet API can be pretty slow, but you should see the transformed planet records returned as JSON. Back in our planets.js file, you might have noticed that we skipped an important step in our response handler. We aren't currently handling any errors that might occur. Express route handlers can take a third argument called next, which we can pass any errors to that occur when handling a request. We want to make sure our errors are being handled when doing any async work. So what we need to do is add next as the third argument to the response handler, wrap the await call in a try-catch block in order to catch any rejected promises, and pass the caught error in the catch block to next. Now we'll implement the planets since year response handler. It's very similar to the last route, but we're using the year parameter, which is part of this route's path. After saving the file, visit localhost 3000/planets/sense/2020 to see all planets discovered since 2020. Again, you should see a JSON payload of transformed planet data. Now we'll create a custom middleware. One of the benefits of using router instances to organize your code is that you can define middleware which is only run for the routes attached to the router instance. You probably noticed that the Exoplanet API can be pretty slow, so let's add a middleware that times how long a response takes to serve. We'll start by passing a function that takes rec, res, and next as arguments to router.use. Let's declare start time using date.now. This will give us the current Unix timestamp in milliseconds. Then we can attach an event listener to the response object to listen for the finish event. The finish event is emitted once the response has been sent. We'll create an in variable with the time when the finish event is fired. To get the elapsed time, we'll subtract the start time from the end time to find out how many milliseconds have elapsed, and then divide by 1000 to get the time in seconds. We'll console log some information about the request, like the method and the URL path, and also how many seconds it took to complete. We also need to make sure we call next outside of the event handler. Otherwise, our request would never complete. Reload the Planet Sense page and then check the console. There, it took 0.821 seconds to complete the request. This timing middleware is just a simple example of a custom middleware. In production, you'd probably want to use a package like Morgan or some other request logging middleware to get this information. To recap, in this tutorial, we created a file to hold our routes and exported a router instance. We handled errors that might be thrown when using async and await in a response handler and passed them to the next function. And we created a middleware in order to time the routes associated with that particular router instance.